Hi guys. Okay, today, right, this is your first lesson, okay, of remote teaching. So I'm going to draw you a little diagram and explain what relative masses and moles are. You've then got some worksheets or you've got a booklet, and I'm going to give you a couple of assignments from that booklet. So grab yourself some pencils, because what would be really helpful is if you made notes on this as you went along. So you've been given an exercise book, okay, or grab some paper and crack on. All right, so today we're looking at relative masses and moles. Okay, so first thing I want to tell you is, what does relative mean? Obviously, we're not talking about your aunties and uncles. Okay, we are talking about a comparison. Okay, so we're comparing the masses of different elements against other masses. Okay, so firstly, where does mass come from? Well, you'll remember from the first topic that we've done, if I was to draw you this periodic table tile here, we've got a 12 and a 6. We know that this 12 means that in carbon there are 12 things in the nucleus, so I'll draw those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We also know, because of this number here, this 6, that tells us that 6 of these are protons. 1, 2, 3, 4, 5, 6. And therefore the other 6 must be neutrons, which I'm going to do green. Right, there we go. 2, 3, 4, 5, 6. So all of the mass in an atom is in the nucleus there, okay? And each proton and each neutron has a mass of 1. Okay, so if I make a note of that as well. Proton equals 1. I just realised I've done that in the wrong colour. Neutron, sorry, bad Steve point there. Neutron equals 1. Okay, and a proton also equals 1. We also know that around the outside of the atom, we've got electrons. We know the number of electrons must equal the number of protons. So we've got 6 electrons. But the electrons have got a mass of virtually 0. Okay, virtually 0. So we don't really need to take those into account when we're looking at mass. So you may have gathered from that then that relative atomic mass, relative atomic mass, okay, which is abbreviated to AR, okay. For example, for carbon 12, also known as 12C, like that, because it has 6 protons and 6 neutrons, it has a mass of 12, okay? There are no units for this because they're just an arbitrary measure, okay? So that just means that there are no units for it, for relative atomic mass, okay? We compare the other elements to the relative mass of carbon 12. So if carbon has got a mass of 12, hydrogen has got a mass of 1/12. Okay, so hydrogen's mass is 1. All right, and we know that hydrogen has only got 1 proton, okay, and 1 electron, and so therefore its mass is 1. Okay, does that make sense to you? I hope so. So that's relative atomic mass, okay, and we've got its brother, it's relative, so it's got a relative formula mass, okay, and that is abbreviated to MR. You need to know those things. So relative formula mass is quite simply, it's the sum of all constituent atoms in a molecule. So what that means, constituent just means all of the atoms that make up the molecule, okay? That make up the molecule. So if I had a very simple compound, okay, let's pick water, because water is pretty simple, okay, H2O. Now in water, we know that we've got oxygen. Oops. We've got oxygen there, okay, which I'm going to colour in red. And I'll just go red there like that. And then we've also got two hydrogens attached to it, okay, like that. Okay, hydrogen and two oxygen. So we've looked at the hydrogen. The mass of hydrogen is 1, and it's got 2 of them. 1, and oxygen. Let's write that in there. Okay, oxygen, if you look on your periodic table, has got a mass of 16. All right. So all we then need to do is add 1 hydrogen plus 16 plus the other hydrogen, and you've got an MR, okay, of 18. All right, so all you have to do when you've been given a chemical formula like that is add up the mass of each constituent element. That 2, okay, means there are 2 of the previous atom or element. So in this case, you can see there's 2 hydrogens. There they are, 1 and 2. All right. So there's one example. Another example would be sulfuric acid. I'll just draw a little line like that. H2SO4. Now you can see that's getting a bit more complicated. Okay, but you can see that we've got 2 hydrogens, 1 sulfur. Sulfur is 32. Okay, and we've got 4 oxygens, and we've seen that oxygen is 16. Okay, so 2 times 1 plus 32 plus 4 times 16. That 4 tells me there's 4 times 4 oxygens. All right, so if I just work that through, that equals 2 plus 32 plus 64. And if I add all of that up, then I get 98. Okay, what's the unit here? Well, as I said before, there are no units, okay, when it comes to relative atomic mass. If I was to draw your diagram of H2SO4, by the way, like I have done here, then we'd have H, okay, O. You know what, I'm going to rub that out. Where's my rubber? But my kids must have nicked off with that. Okay, and then a big S in the middle. Okay, and then another O there, and another O there. Okay, so you can see we've got 1, 2, 3, 4 oxygens, 4 times 16. We've got 1 sulfur, which is 32, and we've got 1, 2 hydrogens there. Okay, I'll just give you a little bit of colour in there. Sulfur we tend to put in as yellow. Oxygen, a lot of the time we colour it red. Okay, like this. And then I've done the hydrogens, I think, in this colour here. Okay, so you should be able to see then where relative formula mass comes from and how we calculate it just from those couple of examples. So what I'd like you to do now is pause this video. Okay, this is the first part of your work for today. Okay, and what I want you to do is answer in the book that's attached to this. Okay, I want you to answer questions 21 to 23. Okay, do it on preferably, I'd like you to do it in a Word document, and I want you to hand it in. Okay, so attach it back onto this assignment when you're done. Okay, there'll be another piece of work from that same booklet that I want you to do. So don't hand it in until you've done this bit, watch the next part of the video, and then completed the second task that I'm going to set you as well. Don't forget, I've got you twice today. Okay, so therefore I'm going to set you 2 lots of work in one go. Okay, welcome back, guys. I hope you've managed that okay. If you've got any problems with it, any issues, please ping me a message or email me. I'm now going to do the second part, which is, of course, moles. Now, when we say moles, obviously you think probably of a furry little creature or a kind of blemish on the skin. We, as chemists, do not talk about those. We're talking about this is a chemical quantity, all right? So a mole. Let's take you and think about language and how we use language. A mole simply is just a number of particles. Okay, so that could be atoms. Okay, single atoms. I'll draw a couple of just atoms. Okay, obviously they're going to look the same because well, in an element anyway, they're atoms. It could be a number of molecules like the ones we've seen before. Okay, like the one we've seen in the last part of this lesson. Okay, and so let's draw a couple of water molecules. Okay, it looks a bit like Mickey Mouse. Okay, those of you, Disneyland seems like a long time ago, doesn't it? Okay, so we could just have, so it's a number of particles. Okay, you could even have, okay, if we're thinking into the future, when, you know, we could be looking at a number of, for example, electrons. Okay, you can have a mole of electrons as well. Okay, so I'll just do some tiny little blue dots like that. Okay, there's a mole of electrons. It's not a mole of electrons, but we can have a mole of any of those types of particle, right? So all it is a number of particles, okay? It's going to look kind of big and scary, but you don't need to be worried about it. So let's have a think about language, right? So if I said to you a dozen, then you should know that a dozen equals 12, right? Okay, if you've got a pair of socks, then you know you've got 2. And it's the same principle for a mole, right? It's just that the number is a bit more complex. So a mole is 6.022 times 10 to the power of 23. This is also known as Avogadro's number, not avocado's number, Avogadro's number, okay? And so in a mole, there are 6.022 times 10 to the power of 23 particles. Now, I'm hoping that in maths, you know what the standard form is. And so if I was to draw out 6.022 times 10 to the power of 23, it means I'd need to move this 23 places that way. Okay, so 6.022, and I need 20 zeros on the end now to make that up to 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 21, 22, 23. Okay, so can you see why we don't write that out every time? Okay, because it's a waste of graphite or ink. So when we're looking at moles, if someone's saying how many moles of a chemical do I have, well, it's dead easy to calculate this. We can calculate moles from relative atomic mass and mass, okay? And that formula is this. I'll write it out here. Moles, okay, or number of moles equals mass and we're measuring mass in grams here, divided by relative atomic or relative formula mass. Okay, so again, if I just give you a couple of examples here, we looked at sulfuric acid here, okay, H2SO4. If I have got, let's say I've got 4.9 grams of H2SO4, of sulfuric acid, how would I know how many moles I've got? Well, you'll see that we know what the relative formula mass is. Okay, so our relative formula mass is 98, and our mass, obviously, is 4.9 grams. So all I have to do, okay, is plug that into the formula. Okay, and if I do mass as 4.9, and I divide that by my formula mass, and my formula mass is 98. Okay, what do I get? That equals 0.2 moles. Okay, 0.2 moles. Okay, can you see how we do that? We divide our mass by our relative formula mass. Okay, it's as simple as that. I don't want you to get too worried about this big number, but you need to remember it's called Avogadro's number, and you should try and remember that it's 6.022 times 10 to the power of 23, and then it's just massive. But all you need to really know is that a mole is just a number of particles. And we can use that number of particles to calculate the number of moles. We can use it to calculate mass if we know how many moles and we know the relative formula mass. So now that you've should have that fixed in your head, what I'd like you to do is answer questions 25 to 34 in your booklet. Okay, and then there is also an exam question. Right, that should keep you occupied for around about the same amount of time as our lessons would have been. If you've got any questions, email me or put a comment on the team. I think that you're able to do that. If not, just email me and I'll try and sort that out for you. All right, I hope that's okay. Remember to wash your hands, guys, and stay safe. Bye.